Hello everyone, I am Shiv Prakash.
Good evening.
Research Scholar Department of Electrical Engineering, IIT VHU, Varanasi. Please mute yourself, all of you. If you
Good
have any,
evening, sir.
okay, good evening. Wait, some more student try to join. Okay, everyone, let's start the session. Yes, some question remaining from the previous class, and I want to just explain that question. After that, I will start further to the questions. The question that this question is simply asking the current flowing through the 10 ohm resistance. This type of question you can simply solve by using a KCL at this node. Or there is a current is given, then what is this current? 1 ampere current is flowing upward direction, then I current is flowing to this one. Then what this current? This current is simply I minus of 4. Current is I. Okay, I minus 1 current flowing here, then I joined here, after that I current flowing through this branch. Simply check the polarity according to the current flowing, simply here also plus minus, so plus minus, you can apply KVL in this way. Then take the first sign which one is talking, like minus 5V, 5 volt, then plus I minus of 1 into 5 ohm, again this resistance 5 ohm, current is passing through it is I into 5, then this one plus I into 10, 10 ohm distance. Okay, you can solve this one. I will current it. I will get that clear. So minus 5 plus this one 5I, this one minus 5 plus 5I plus 10I equal to 0. Plus 5I plus 5I plus 10I is equal to 20I is equal to minus 5 will be 10, then I is equal to 0.5 ampere. Okay, then this is the next question. The circuit shown in the figure represented as is about the what type of current source is this? Is one is a voltage controlled voltage source or voltage controlled current source or current controlled current source or current controlled voltage source. How can you define all
Can
of
you,
these?
sir?
Yes, yes.
Yes,
Sir,
sir.
can you repeat the past question?
Yeah, this one. In this question,
Yes, sir.
simply I is given. Then no need to take another variable for the solving this question. Simply I is here. Then we have to find this branch current according to this one. This one I taken the I minus 1. I minus 1 current flowing through it like that. Then after I is joined here. After that, this is I. I minus 1 plus 1 is equal to I is flowing through it. If the current is known, all of the current is known, then after you simply apply the KVL in this loop, whole loop. This one by the KVL. We will get this one. Like first polarity of this voltage source is 5 minus 5. Okay, then after is 5 ohm resistance and current passing through it I minus 1, I minus 1 into 5. Then this resistance is 5, current is flowing through it is I into 5, and this resistance 10 ohm current flowing through it is I into 10 is equal to 0. Simply KVL. After that you can solve like algebraic equation of the mathematics. 5 and 10I is equal to 20I. Then 5 is minus 10, 20I minus 10 is equal to 0. Then 20I uh, 10 minus of 10 is going to the right side, that's why it will be 10. Then I is equal to 0.5. 10 by 20 is 0.5 ampere. It's okay. If there is not given any notation in this question, then simply let the V of this one and apply KCL in this node. Kirchhoff current law, input current, output current, all of them you can see. Simply KCL.
So, sir, because of the current direction, we have kept plus to minus for the 5 ohm resistor, right?
Yes, what? Can you
That,
repeat?
that 5 ohm resistor is there, no? That
Ah,
is from plus to minus we have taken. So that is
because
because of the current
already is
direction.
given. The current direction already is given.
Yeah, that's what. Okay.
That's why the entering point is positive of all the current and capacitor, resistor, capacitor, and inductor. That's why I taken a 5 plus at the entering point. If the plus is enter from any of elements, that means that element is just a sink. We have like a sink, not a source. If the positive current is go leaving from the positive, it means that is known as the source. It means that is supply the current, supply the power. It means this is a sink, absorb or dissipate the energy, that element. Like here, this is the 5 volt of element. Then this one is a current flowing to upward. It means from leaving from the positive terminal, entering from negative. That's why this is behave like a source. This is a current entering from the positive. This will behave like a sink. Later, the subject of the topic, you will taught about this one. I will teach about this one all of thing, sink and source and direction. Sometime we will observe the some voltage source also absorbing some power, taking some power from the another source. That case, in that case, current is entering from the positive in the voltage source also. So these are the notation type where you represent the source and sink. Okay, let's start this one. Voltage control voltage source or voltage control current source, current control current source, current control voltage source, depending on the all of thing. In that case, in this case, you have to observe the symbol of the sources. Here is the given the arrow. Arrow is a symbol of current source. All of you know that this symbol, arrow symbol, is denoted the symbol of current source. And if there is a plus or minus terminal, anything, this is denoted like voltage source. Okay, here is the arrow. It means this is denoted the current source. This is the current source. Okay, then there is a two current source, voltage control current source or current control current source. Then after you have to observe this one. What is the variable in this case? Here A1 is some constant quantity, I is the variable, I is the variable, and I is defining here, and all of you know I is a symbol of current. No, current is denoted by the I. It means this is the current control current source. In this case, this is the current control current source. Why? Because of the symbol, this is the current. It means this is denoted as the current source. The symbol after that, this is a controlled by which one? Voltage source or current source. If there is any resistance and the voltage of this resistance is Vx, and that Vx is here, suppose this is the AI into Vx. In that case, this current source is controlled by this voltage, because of here this is the voltage of this across this resistor. In that case, this is denoted as the voltage source, a current source controlled by the voltage. It means voltage controlled current source in that case. But here, this is a controlled by the current only. That's why this is the current control current source. And voltage source, if there is, then voltage source simply represented by plus or minus, plus minus, like that. And current source is represented like a circle between the arrow is in the circle. Okay, some of the example here, how define the current source, voltage source, like that. You can observe this is the plus minus, it means both are the voltage source. Okay, both are the voltage source, but how is it will control? This one controlled by the voltage V plus minus V1, and this is the V1, mu into V1. It means this voltage source is controlled by V1, and V1 is the voltage of this terminal. That's why this type of structure is known as the voltage control voltage source. This is a voltage source controlled by this voltage. It means this is the voltage control voltage source. Same thing, this voltage source is controlled by this current I1. R into I1 is here. It means this voltage source is controlled by a current source. That's why this is known as a current controlled voltage source. Same thing here. This is a symbol of current source. It means this is the current source. Fine. But how it will control? From the V1. V1 is the voltage at this terminal. Then you can say this structure is voltage controlled current source, because of this current source is controlled by the voltage. Same thing here. This is the beta into I1. This I1 is presented as current flowing through this one. It means this current source is controlled by a current only. That's why this structure is known as a current control current source. Okay, this is the four structure only, how it is usually represented. Current controlled and source. Okay. So next questions. Consider the circuit shown in the figure. The current I flowing through the 7 ohm resistor between P and Q. Is asking this current I flowing through the 7 ohm resistor, and 5 ampere current is given in this branch. Then how can you solve this type of question? Okay, let's try to solve this one. First of all, in this question given as this will short circuited to each other. It means if I given some point here, point A and B, then A and B is the same point because of the short circuited. Here is a short circuited is given, simply connected to A to B, then simply there is a 2, is a 4 point P Q, P here, Q here. I taken as the A and B here, A and B. Okay, sorry, A and B is the same point. A because of the both are connected to this wire. Then P and Q resistance is as 7 ohm. 7 ohm resistance is here, and we have to find the current through it. Then after P to B is 6 ohm resistance. P to B, B is same point, have 6 ohm resistance. 6 ohm resistance. Then P to A have 3 ohm resistance. Same, A is here also, same point, 3 ohm resistor. Then Q to B is 2 ohm resistance. Q to B is 2 ohm resistance. Same, Q to A also 2 ohm resistance. A and B is the same point. Q to A also 2 ohm resistance. Okay, and a current source is represented as Q to A. Q to A have a current source like that. This is the 5 ohm, 5 ampere of current from Q to A. This all is the same point. Then you can solve this one. These two resistance connected in parallel, these two resistance is connected in parallel. I written as P, Q, a resistor is 7 ohm, and we have to find the current flowing through it. These two are connected in parallel. And what is the equivalent resistance? R equivalent multiplication of these two divided by sum of these two is equal to 2 ohm. These two resistance are connected in parallel. It means multiplication of 2 is 4 divided by 2 plus 2 is 4 only 1.
1 hour.
Okay. This is the 5 ampere of current. Then what is the this current? This current is same as this current because of these two resistance connected in series only. If you find this current, then this current will be same. Current source have this point, 1 point, secondly this point. It means 7 plus 2 ohm, 9 ohm resistance is connected parallel with 1 ohm because of current is divided between 2 only. 1 ohm and this 7 ohm. This is the same. All of this is connected in parallel series only. Here current is not divided here somewhere. That's why this current is passing like that, flowing through it. Okay. Then you can apply current divider. I is equal to, then what is the current divider rule? Total current into opposite of that branch is 1 ohm divided by of total resistance 7 plus 2 9 plus 1 10 is equal to 0.5 ampere. 0.5 of 0.5 current pair of current is flowing through the 7 ohm resistor here. Because of these two is parallel, these two is parallel to each other, then the both are the 6 3 is 2 ohm, this is the 1 ohm resistor, and the current source is across the 1 ohm resistor. You can find like that. This is the next question. There is some of the part of this question is missing from here to here. I written here. Right. It means that is given as sum of n is equal to 1 to 10 in is asking the question. Where I1 is given as 3 ampere, 1 milliampere. Okay. I1 is given. Then see the question asking. In the circuit given below, you can see there are n current sources connected in parallel corresponding to nth row. N connected in current source connected in parallel corresponding to nth row. It is given that each current source of row n is carrying the current of in. That the example is in the row third. Suppose this third row, each current is carrying is I3. It means this all current is I3 here, I3 here, I3 here, like that. Then find the sum of current I1 to I10. It means sum of the I1 to IN n equal to 1 to 10. if the I1 is given as 1 milliampere. It means this current is given, I1 is equal to 1 milliampere. Okay.
Excuse me, sir.
Yes.
This problem was solved by madam on Saturday.
Okay. No problem. I can solve again also. This is given as the 1 milliampere current. Sorry. This is 1 milliampere. Then this is given as same all the sources is this one is the like a I2. This is also I2. All the same current. This is I10 row third or row 10 is current of I10 like that. Then you are asking the question what is the sum of I1, I2, I3 all of the sources. Okay. Then how can you solve? Simply find this one is given as 1 milliampere. Then what is this current? Is all of the current carrying by suppose I, then all of the both are current carrying by I by 2 and this one also I by 2. Then what is this one? This will be I by 3, this will be I by 3, this will be I by 3. That same here I by 4, I by 4, I by 4 and I by 4 because of the main current is I milliampere. I taken as I. Then this is divided into two part. This is 3, this one 4 part. Same thing dot. This will be current is I by 10. This is also I by 10. Then for the sum of the current, summation of n is equal to 1 to 10 In is equal to simply I1 plus I2 I3 dot to I10. I1 is simply 1 milliampere taken as 1, I by 2, I2 is I by 2, it means 1 by 2. This will be 1 by 3, 1 by 4, 1 by 10. Simply you can add all of things, you will get the final answer. How can you add? Or simply you have to take an LCM for all the denominator, or you can simply use the calculator and find the value of inverse of all of things. 1 plus inverse of 2 plus inverse of 3 plus inverse of 4 plus inverse of 5
So
like that.
sorry to intrude.
Yes.
Sir, in final examination, they will allow us to carry calculator.
Yes. Calculator is allowed.
Okay, sir. That is why. Thank you.
Yes, sir. Just simply use the calculator, all of the inverse, we will get the final answer. This will be a 2.9289 milliampere or approximately 2.929 milliampere. I think first one. Okay. Next question is again second below. Find the voltage across the capacitor after t is equal to 3 nanosecond. Given the initial voltage across the capacitor is minus of 5 volt according to the polarity shown below, and the value of k is equal to 3. There is a circuit, simply I take this circuit, is a symbol of current source, representation of current source as some capacitor. Okay, this is denoted as the k into ix. It means this is the current source and controlled by the current only, because is the symbol of current and flowing through this branch. And the polarity of this capacitor is given as minus, and this is the plus. V capacitor is asking the question, this is the value of C. In this case, you can see here this capacitor is working like a source because of the current is flowing through the leaving from the positive side and entering from the negative side. It means this capacitor is behaving like a source. Then how can you represent? There is an initial voltage also given. Then you can extend this one with the initial voltage, simply current source, and direction is upward. A capacitor is denoted as a symbol of capacitor, then initial voltage source. Initial voltage is behaving like a voltage source. And this is the symbol of this one, B capacitor. Okay. Then what is symbol? Symbol is same to as the capacitor symbol. This is the plus, this is a minus. I wrote denoted as Vi as the initial voltage of the capacitor, and current is flowing like that. So what is the voltage across this terminal is same as V capacitor. Then you have to apply a KVL. This is the same as V capacitor is given here. This is minus. This is also because of this parallel connection, and this is also is V capacitor. From here to here, this is negative. This is sorry, this is positive. This is in the question given negative. Then take negative here, take positive here. Okay. Then apply the KVL. If they apply the KVL here, then what happened? First terminal is plus V capacitor. Then after current entered from negative, this is negative positive given in the question polarity, entered from this one negative 1 by C integration of I, this current is K into Ix, K into Ix into dt plus then after this voltage source minus of Vi is equal to 0. This is the KVL across this loop. In this case, the polarity is given, then take the polarity according to this one. Okay, if any capacitor is noted like that only, a symbol capacitor with initial voltage is denoted like a capacitor and a voltage source. This polarity is same as this polarity, the capacitor, and V I of the initial voltage. Total is the this one, V capacitor. Okay, then we'll get this voltage equation. Then what is the V capacitor? V capacitor is simply integration of kx into dt initial terminal is also added here, then no need to take initial voltage or other. Then this will be K by C. Ix is a constant. Then integration of 1 dt is time t plus Vi. K is given in the question 3 and time is given 3 nanosecond. Capacitor value is also given 1 nanofarad. K is 3. I don't know. T time is 3 nanosecond 10 to power of minus 9. Capacitor value is 1 nanosecond 10 to power of minus 9 or nanofarad plus Vi initial voltage is given minus of 5. Then this will be minus 5. Then 10 to power 9, 10 to 9 cancel out. Then this will be 9 into Ix minus of 5. V capacitor voltage of, okay. Then you have to find the Ix. You can find Ix from this circuit.
Sir,
Yes.
can you elaborate the value of V cap?
Okay. Once again, a simple capacitor is represented like that. C plus minus B capacitor. Okay. If there is no initial voltage there, if there is an initial voltage, then you have to represent the initial voltage also. Then that one represent as the capacitor and a voltage source, initial voltage. That sign of that initial voltage is same as the capacitor terminal voltage. Okay, then this is the C, this is the initial voltage of that capacitor, and the terminal of the whole is denoted as V cap. Total voltage is V capacitor. Symbol same, plus minus. Same thing I did here. A capacitor, simply this is a capacitor, symbol is given in the question, minus, this is plus. Same thing I applied here, a capacitor and a voltage source. Okay, plus is sign is same thing, plus sign, minus is minus, and sign is the same as the according to given this one. And total capacitor voltage is V cap is a capacitor and a initial capacitor voltage. Then this is a current flowing through it. Then current, we have to apply the KVL. Our current is here. Then V capacitor is this voltage drop at the capacitor is 1 by C integration of current. Current is a KIX given in the question. I taken same thing here. Integration of I dt, K into Ix into dt. Then Vi is same sign, negative sign I taken because the first sign is all taken. Then Vi is the initial voltage. Then capacitor voltage is same thing is one. If you integrate this one, I K into Ix, K is constant, Ix also constant. Then only 1 is there. Integration of 1 dt is T. Then K into Ix into T, this is the C plus Vi. I put in the all of value, remaining the Ix because the Ix is unknown is there. Now you have to find the Ix value from this circuit. Then what is the Ix? Let's let try to find the value of Ix.
1/3.
1/3.
Yes.
Okay. 10 volt. This one 55863. 5 ohm. Five ohm. This is also 5 ohm. This is the 8 ohm. This is 6 ohm. This is the 3 ohm. Current in the question given asking about this branch Ix. Then you have to find the Ix here. How can you find this one? You can find simply by apply the KVL and KCL. Okay. Simply I taken the equation current of this one is I, this one is I1, this one is I2. Okay. It means this current is same as the I2 flowing through this one, and I2 current is divided into two parts, in 6 ohm resistance and 3 ohm resistance. Same you have to apply the KCL here. Sorry, current divider rule. CDR. All of you I think know about the current divider rule. Let's try to find a current source and simply if there is two resistance connected in parallel, current is I is flowing through it. This one R1, this one R2. Take the current as I1. This current is taken as the I2. Then what is the I1 and I2? And what is the KD? CDR. Suppose simply I taken as voltage source V here. Then apply the KCL. KCL is what happen? Incoming current suppose is I, out current is taken as a negative. I minus of I1 minus of I2 is equal to 0. Then what is the I? I is equal to simply I1 plus I2. Then what is the I1? V divided by R1, V divided by of R1 I1 plus I2 V divided by of R2 voltage source divided by the current source. Divided by the resistor. Then what is the I? Okay, V can take common 1 by R1 plus 1 by of R2. Then LCM this one is R1 into R2. This will be R1 plus R2. In this case, what is the total voltage? Voltage is multiply by the here I into R1 into R2 divided by of R1 plus of R2. Okay. Then what is the current of I1? I1 is V divided by of R1. Simply I1 is equal to V divided by of R1. And what is the V? V is I into R1 into R2 divided by of R1 plus R2 and this R1 divided by of this R1. R1 will be cancelled out. I1 is equal to I into R2 divided by of R1 plus R2. This is from the from the current divider rule. Same thing I2 is V by R2. R2 will be cancelled out. Then I into R1 divided by of R1 plus of R2. I1 and I2. It means here we observe that I1 is equal to total current I into R2 divided by of R1 plus R2. I current is here, total current I is divided into two part, I1 and I2. Then I1 is equal to I total current into R2. It means opposite resistance. Simply total current into opposite resistance. It means R2 divided by of total resistance is the current flowing through this resistance. Same thing apply here. I2 is current flowing through it, this branch, and divided into two part. Then what is the Ix? Ix is equal to total current of I2 into opposite resistance is 3 divided by of total resistance 6 plus 3 is equal to I2 divided by of 3. Then you have to find the I2 only. How can you find the I2 here? If you find the I2, then you will get the Ix.
Sir, slide not visible.
Okay, I understand. I think there is a technical errors.
So,
It's fine, everyone.
Yes, sir.
yes, sir.
Okay. Simply for this question, then there is echo of voice. Okay. For the Ix, simply current is flowing I2, then simply I2 into opposite resistance 3 and divided by total resistance. Then I2 3 plus 6 is 9, then 3 3 is 9, I2 by 3. You have to find the I2. For the I2 is current, this one current, this is I1, this is I2. Simply this voltage is appears across this one node, then this one node also. This 10 ohm resistance, then 10 ohm of voltage source. Then what is the current is here? I write here again. This is also 10 ohm resistance. Then what is the total resistance of this one? Equivalent of this parallel combination. 3 and 6 is 3 6 18 divided by of 9. This will be 2 ohm, and 8 ohm here. 8 2 is 10 ohm. Both are the same. 10 ohm resistance flowing through it. This is the I1, this is I2. This voltage is 10 volt. What is the current is this one? 10 divided by resistance 10 ohm equal to 1 ampere. This is also 1 ampere. It means I2 is equal to 1 ampere current, and Ix is same I2 by 1 by 3. Then this will be 1 by 3 ampere. The Ix is there. Then what is the V capacitor? 9 divided into Ix is 1 by 3 minus of 5 is equal to 3 minus 5 is minus 2 volt. Minus 2 volt is the final answer of this question. Okay. Simply we have to solve this question. The capacitor is defined. Then after you solve this one. Okay. This is the next question. Let's say you are in your college lab and you are given a voltage controlled voltage source. It means there is a voltage source controlled by the voltage. Here you can vary a K from -1 to 0.8. Also you have a 3 resistor 1 ohm, 10 ohm and 100 ohm with you. Now choose any one resistor and K value between the given range so that the equivalent resistance between port A1 and 2. Yes.
Sir, above for capacitor, just multiply with Ix to give voltage, sir.
In this question.
Yes, sir. We
Yes,
found the Ix value now, sir.
yes, yes,
We substitute into the capacitor value to get the answer, sir.
yes, yes, same thing. The capacitor voltage is depending on the Ix value because of the here is given a current is a K into Ix, and it means the Ix current is flowing through it like that. Then this capacitor is asking the total voltage of this capacitor. Then first of all, if you know about the capacitor equation with Ix, then Ix find from here, then this Ix is putting here, or you simply find the Ix value, then this Ix value is putting here. K into Ix, K is given as 3, Ix is simply 1 by 3. Then this current source is 1 ampere. This 1 ampere of current flowing through it, then this find this circuit total circuit voltage by this equation. Okay.
Yes, sir.
Simply this circuit is given and asking about the value of K
Sir,
and yes,
sir,
yes, yes.
can you scroll up the sheet?
Which one? The this one?
O- Okay, sir.
Oh, thank you. So we are asking about the value of K, which is the range of -1 to 0.8, and the resistor we have to connect any two terminal 3, 4 and 5, 6 is given. One resistor and a wire you connect. It means you simple you connect a wire and a resistance through it. Anywhere you can same resistor connect here also. This will be R. This is the Vx. Then find the value of K and R for the maximum equivalent resistance here. Okay. Simply take current question I. Then take a loop. There is a loop forming between them. Current is flowing from here to here. That's why positive here, negative here. Current is flowing I. Then apply the KVL in this loop. Loop 1. What is the KVL? Simply apply same voltages minus Vx here. Then after plus of K into Vx. Then plus of I into R is equal to 0. Resistance we know about V by R is equal to R resistance. Sorry, V by I. Here V is Vx. You have to find Vx by I. How can you find this one? Vx you can common. This will be minus of 1 plus K is equal to minus of I into R. You can multiply a minus whole equation. Then this will be Vx. This will be 1 minus K is equal to I into R. Then Vx divided by I is equal to R of equivalent R is equal to R divided by of 1 minus of K. Now, when this will be maximum? When this will be minimum and this will be maximum. The maximum R is equal to, the question is given 100. This is maximum resistance, and the value of K, minimum value of K in positive. If there is negative, then maximum one negative will be positive. This is the value is more than the positive value. That's why take the positive value. The positive value minimum is given as 0.8 minus 1 to 0.8. That's why this will be 0.8. Then these two is asking in the question. Resistance R 100 ohm, value of K is 0.8. R is 100,
Sir,
K is 0.8. Yes.
sir, I don't understand the question. Like
Which one question?
how you this question number 6. How you made this connection wire and resistor? It
Okay,
is
okay.
asking to made the connection between port 3, 4, 5, 6. So how you make this connection directly?
Okay. Same question I written here. I write Vx is given. There is some voltage source. This is port 1, 2, 3, 4, 5, 6. This port is here also na 5, 6.
So we can like consider the port there also. Like
Yeah, same thing.
yeah, same thing. Basically.
There is a question is given that the question that you can connect one resistor and one wire between port 3, 4, 5, 6. Anywhere you can connect a single wire and a resistor. So 3 and then 4. If you here, if you want to connect a resistor and you want to connect a wire here, you can do it this one also. Okay. You take a current I, then then there is this one plus minus, and apply KVL here from this loop. In that case, what the loop is? This one is Vx plus I into R plus K into Vx is equal to 0. Then I into R plus minus of 1 plus K Vx is equal to 0. Then you can transfer 1 minus Vx there. Then I into R is equal to 1 minus K. This will be opposite. This will also same. R divided by of 1 minus K. This is also same as the previous one.
Sir,
Yes.
but we cannot connect like resistor between 4 and 5 now, sir. Like that.
No, there is a not connection anything. Direct not can't connect directly because of if you connect like that, Send 3 and 4 and 5 a register,
Yes, sir. Yes, sir.
and then a wire is connected here. Okay,
Yes,
that's all like that.
yes, yes, sir.
Let's check what happened in this case. Current I is flowing like that. There is some confusion, I think, in the question. Not clearly says where you can connect. In this case, first one is minus of k into Vx, then plus of I into R, then this will be minus of Vx. There's a different thing, I think. But there's a problem in this question if you know that minus is common, 1 plus k is there, is equal to I into R, sorry, this is a Vx, I into R is equal to 1 plus k into Vx, then Vx by R is equal to R divided by of 1 plus k. In this case, if you take a k is equal to of minus 1 is the minimum value for taking all of the maximum, then this will be infinity, then open circuit is there. In this case, but there is some little bit confusion in this question, not given properly where you have to connect. It simply mentioned 3 4 5 6, that's why there is a confusion. But in this case, if you try this type of question, but you have to take it as the polarity. This is a minus, this is a plus, this is a plus, this is a minus. Don't try to connect plus to minus, minus to plus. Okay. Then try to connect the
So
plus to
we
plus.
shouldn't connect like that, sir. Plus to minus like that.
No, simply if you connect a plus to minus, minus to plus, then you will opposite the polarity, all of the polarity. Then there is a circulation current only flowing through it, not going to other side. Simply if you connect like that, or register like that, all of the plus possibility. Now, if you try this type of connection, this plus is connected to the minus, and this minus is directly connected to the plus. There is between short circuit like that. This minus plus.
Yes,
But
sir.
in this question, they will be given some exact configuration to show the where you can connect. There's a lot of possibility in this question. You're not mentioning anything. It means you can connect here also.
Sir,
This is a short
in this
circuit.
question, is necessary to draw the circuit as you draw, isn't so?
Yes, yes. There's a lot of possibility. No, there's not mentioned. Then you can connect a resistor here and short circuit here, a resistor here. Because I've not mentioned anything.
Sir, if we redraw the circuit, the answer is we get various answer, isn't so?
Yes, yes. There's a lot of chances to connect a wire because there's not mentioning. If there's mentioned 3 and 4 or like a 3 and 5 and 4 and 6 like that. If they mention between them, then you can connect 3 to 4 a wire and a resistance. This will be mentioning like that only. But as mentioned directly 3 to 5, 3, 5, 4, 6, 3, 4, 5, 6. That's why there is confusion. Little bit
If they didn't mention the ports, what we have to do, sir?
This type of question, I think there is some confusing question. Which one is a possibility is there? Then you can connect.
Okay, sir. No issues.
Yeah.
Thank you.
Okay.
Sir, this slide will be uploaded.
Yes, yes, yes. I will upload.
Okay.
Calculate the effective resistance of the below infinity ladder question to solve the terminal
Sir,
A
for
and
this
B.
question, the second one is the answer. On the previous class, ma'am has also taught this one.
All the questions.
Yes, sir. Yes, sir.
Yeah, this one only. Okay, this one also there.
I think so, sir.
Okay, 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 okay. This is the previous year assignment question. That's why. Then the
Okay, sir. Okay, sir. No
so
issues.
will solve.
Okay, sir. Please carry on.
If you have any confusion, then I can solve this question. We'll go
Sir,
through.
we will go with the previous sum, sir.
Okay, okay. This one is fine for you, your side, or there is any confusion?
Yes, sir. This one is new
Sir, you
one.
can teach this sum.
This one new one.
This one is okay. This one
Ah,
is
yes,
new
sir.
one.
This is new one.
Okay, okay. Let's try to solve this one.
Okay.
Find the potential between the two terminal A and B when I in is 150 sin 5t milliampere and C is 2 millifarad. All the capacitors are uncharged initially. It means there is no initial voltage there. Then you have to find the voltage across A and B. This is a simple question, but given in this notation and this diagram, is make that some confusion, because this are the same point, na? Can you observe this one?
Yes, sir. These two are connected in parallel.
And this is also same.
Yes.
It means the same capacitor connected like that.
Yeah. So the total capacitance comes out to be C plus C, that is 2C. Again, 2C and 2C are connected in series. Comes out to be C.
Okay, let's try this one to see. This will CC 2C. Can I return? And you have no
Yes,
confusion,
sir.
na? Then this terminal is A and B is A is here, B is here, and this is the current source. Yeah. I in. This is the 2C. This is the 2C. This is the 2C. Okay.
Okay.
If you find the current flowing through this branch, then simply you apply the voltage KVL and you will find the final answer VAB. Okay. Then this current is flowing I in is divided into two part. This one in this circuit. Okay. Then how can you find this one? Simply you know about the capacitor current I in. I written as this one like I1, this one I2. I in is divided into I1 plus of I2. Suppose there is a voltage. Screen is visible for you, or there is any problem?
Yes, sir.
Yes,
Visible.
sir. It is visible.
Visible.
Okay, okay,
Visible.
okay, okay, fine. I think someone has doubts. Screen is not visible. Please check your side and or we can disconnect and connect again. Suppose this is the voltage, let us check V. And what is the V1? You know about I for the resistor V is by XC, like that, where X is 1 by omega C. All of you know about this relationship for the capacitor. Same thing by
It's impedance, isn't so, sir?
simple impedance goes. That's why.
Okay, sir. Okay, sir. Omega C stands for angular frequency.
Yes, this frequency is given in the question also, 5t omega.
Okay, sir. Okay, sir.
The V by omega C. Then V C, what is the C? Both capacitors are connected in series. Series capacitor is solving as like a parallel combination of the resistor. It means the overall is the C only. V by XC here, or you can see this will be omega C plus V by F 1 by, there is a 2C, that means 2 omega C. Then I in is equal to V omega C plus 2 V omega C. Then I in is equal to 3 V omega C. Oh, sorry. Then V omega C is equal to I in by 3. Okay. Then what is the I1? I1 is equal to V into omega C. V omega C is also already known. I in is equal by 3. I1 is 5. Okay. Then we have to find the voltage VAB. It means this is a positive, this is a negative. For the capacitor, we know about the capacitor 1 by C integration of I into dt, but there is from 0 to t. In this case, because of there is a variable current is there, I is not a fixed current. If there is a fixed current, then we will get simply a constant is there current, and there is not.
Sir,
Yeah.
sir, where is the I current input by 3?
Okay. Okay.
I,
Simply I taken as the V as a node voltage here. Same thing here like that. Then this current is passing I1 here and I2 here. Okay. Then what is the both current? Sum of the both current is I1 plus I2. I have solved this thing. I1 is V by XC. XC is omega C and omega is C. So both, but C is different. This C is 2C in 2C connected in series. There is a total C only in capacitor case. Then 1 by omega C here. Then this is 1 by 2 omega C because of 2C is there. Then total I in is 3 omega C. Then V omega C I find from here. I found V omega C is equal to I in by 3. Then after you have to find the I1. I1 in this case V by XC1, and V by XC1 is 1 by omega C is total V omega C, and V omega C already find here I in by 3. That's why I directly written as the I in by 3. Okay. This is 1 by C integration of 0 to t. I, it means I in by 3. I in given in the question already 1 by 3C integration 0 to t. I in is given in the question is 155 sine 5t. 150 sine 5t into dt. 150 is constant. You can take the outside of this one. 3c. Then integration of 0 to t sine of 5t into dt 50 divided by of c, and this is given in milliampere. Current is given in milliampere. Okay, then you have to multiply up 10 to power of minus 3 here. The integration of sine 5t is minus of cos 5t divided by of 5 from 0 to t. Then put the value of c also. C is 2 millifarad, and there is a 50 divided by 5 50 into 10 to power of minus 3 divided by of 2 milli 10 to power of minus 3 into 5. This will be put the higher side first. This will be cos of 5t minus of cos 0 minus this will be minus will be plus cos 0. This is 0. 10 to power minus 3 will be cancelled out. 5 2 ja 10, 10 5 50. This will be 5 1 minus of cos 5t. This is the total VAB voltage in volt, not millivolt. This is a volt. Okay, this is the answer.
Hello,
Yes.
sir. I want a little clarification regarding uh, weekly assignment.
Okay. Okay. I think assignment
In
2 first.
no, no, sir. In week one assignment, I was stuck in question 4 and question 6. Can you just give a little overview? If you,
Okay. Find the value of equivalent inductor as seen from open terminal of the diagram shown below. You have to find total inductor, na?
so, sir, just I have to find inductor like series and parallel inductor like that.
In that type of question, there is a dependent source is there. If there is a not
Yes.
dependent source or independent source, then you can simply short circuit the voltage source and open circuit the current source. But there is a dependent source,
Hmm.
then simply apply the voltage and current in the final one, where you want to find the inductor.
Like I have to assume.
A voltage
Okay.
source V and
Hmm.
current is given already I, then find the V by I is the same as the inductor.
Okay. First, I have to find the V by I.
Yes,
V
and
and I.
take any loop have some current or any voltage,
Hmm.
then you will find there's a two equation and you can solve. Simply
Okay,
find the
sir. And
V by I.
okay, and in last question, like question number 14, there I have to take the slope of last 0.5 second, like between 1.5 and 2, to solve this type of question. Like here, I don't know what.
Question number 13.
No, 14. Just after below 13.
Okay,
Sir, the screen is not visible for me.
okay. I think there is a different screen I'll choose, and that's why simply the live classes. That's why I'm not solve all the thing, but to simply give some suggestion only. This is I think I see all of the related to the 13th question only. For the current plot is given I1 versus I2, B11. Okay, simply
Sir, I think
apply.
both are different question. Like question number
Ah,
13 is
okay,
totally
okay.
different.
Simply
And
current. Find the current equation, then apply the same equation is here. Find
like
the
sir, in this question, like if I have to put the value of di by dt,
yes.
then which slope is like I have to put to find the v11, v12? Like
Sir, at what instant of time, sir? I mean, in that
yes, sir. At
whole,
what instant of time?
in the way they are not given at
No, no,
what
no,
instant of
no. There is not given in the question at the time, but you have to find the total equation. Then after apply the all equations there.
Sir, this type of question I have not done.
So like we can take 0 to 0.5, right? Like
Zero.
slope can be
The 0
common slope.
to 2 millisecond, all of the slope. I think you have to
Sir,
take
what will be the slope of
0 to
total?
2, 0 to 2.
Yes.
Simply apply linear equation formula, then find partwise wise equation, then add all of thing as I1 and same thing for the I2 and apply the all equation di by dt. You simply, if you do the di by dt of the equation, now simply find a curve like
Hmm.
steep, uh, simply a square curve. Now, so if you do this one like that, if you differentiate this one, na,
Hmm.
so then we will get this type of curve like that. Then simply apply current voltage. This one current. Simply multiply L into di by dt. L is given, di is here. This one. Add those both.
Or like for all instant, I have to add.
There is two instant only, na there.
Yes, two. Yeah.
Or you can find the equation. This equation, this equation, this equation. By using formula y minus y1 is equal to y2 minus of y1 divided by of x2 minus x1 x minus x1. Then you get the current in term of t time, and single t is there. If you differentiate this one, t will be cancelled out. Simply you get the a constant value. Apply this one for this formula, then after this one, then after this one, and add the all of thing. Then
And
apply differentiate.
one more is there, like question number 6.
Sir, but they are asking answer in volts, whereas
Ha,
we are getting waveform.
no, there is a waveform in terms of t. If you differentiate this one, t will be cancelled out, na. Differentiation of t is constant. This is not a t square term anything. Simply you will get the t form only. Then
Sir, but there is mutual inductance also. So L di by dt plus or minus M di2
ha
by dt.
m di only dt, na, di2 only single differentiation, not a double differentiation there. Then
I agree, but L di1 by dt plus or minus M di2 by dt.
yes,
We
you
have to
have
take
to
differentiation of second current also.
so you have to find the both equation I1 and I2 both in terms of
Yes.
t. Then there is only t is there, not t square term. If you differentiate t terms, then simply find a constant, not any t terms.
But we have to add those two waveforms L1 di1 by dt
Yes.
plus M di2 by dt.
Yes, you have to
Then
find
that will
for the
be
two. Oh,
addition of two waveforms will be another waveform, third waveform. Will not get a constant voltage. Like here also you can see one positive is there and another negative is there. So whereas in the question they are asking particular value of voltage. So it can be some constant value as 11, 12, 2, something like that. But it's not like that. No?
no,
In a,
there is L1 di by dt, di1 by dt,
hmm.
na. plus or minus anything, there will be plus m d I2 by dt.
Hmm.
Okay, and
Yes.
you have I1 in terms of t only, not t square is there.
Agree. Agree.
I2 also in the term of t.
Yes.
Then we have differentiate both with
Hmm.
respect to t. Then t will be cancelled out for the both. Then there is only constant value, na. Just try
But
by your
one will be positive, another will be negative. Constant value. Agree. Let
ah.
us say plus 5 and minus 5.
Then
So
plus
what should be
minus
the
is
answer then?
plus minus you simply add, na.
Okay.
Add this,
Yes, sir, we got it.
add or subtract. There is a possibility of 0 also.
Hmm.
In this case, I
Okay.
think 0 only. I think we will not. No, there is a different inductor value. That's why not 0. You can simply.
Yes, sir, we will try.
Can I remove this all thing?
Yes, sir. Question 6.
Question number 6. What is this 6? Find the circuit shown below. Given figure current of I, which is in the medial current, na.
Yes, sir, in the middle. Like it will be the same note, na, sir? Your other. Can we consider it as same node?
Same net, okay, but take a current I1 and I2 like that.
You can
Assume
simply apply KVL and get the
KVL,
current.
KCL. You have to apply KVL. There is a current, you can directly find the current in the both cases. Simply apply the KVL, KCL. Now, 3 ohm and 9 ohm is connected in parallel with 1 ohm and 2 ohm, and there is a 10 ohm voltage source. It means current is 10 divided by 12 in one branch, second branch 10 divided by 3. If there is any two current, you can find.
Okay, so thank you.
There is a first of all apply the KVL, the all of thing current, find the all current on all branch, then you will get simply difference between them.
Like sir,
Any
like
one
I
node,
have to take loop
okay.
or something.
Find a loop, anything you can take, but simply any node or 1 or 2, between 1 or 2, or take on between 3 and 9 ohm, take a one node and apply the KCL after finding the current.
So sir, I have doubt like that I which is shown, it is different node or same node?
I is the same node. There is a wire connected to two nodes.
Okay,
Then some current is
between
flowing
1 and
between them.
2 and 3 and 9.
If there is a same register is there, same register is above and below both the same register, and there is a zero current flowing through them. But there is a different register is there.
Hmm.
It means it's not the same as like a 3 ohm resistor. Any current is passing through 3 ohm resistor is same as the 9 ohm resistor. It's not possible. Is there is different in current because of the resistor is different. That's why some current is flowing through I. First of all, find the total current. Solve
Hmm.
all the resistor and find the current, total current uh, outgoing from 10 ohm voltage, 10 volt. Then find the two current, 1 ohm and 3 ohm.
Oh sir, like first I have to remove this I and find total current in the circuit.
Then find the 1 ohm current and 3 ohm current.
Like here 1 and 2 are in series and 3 and 9 are in series. Am I correct?
Yes.
2 series and then 3 by 12. 3 and 12 are in parallel.
No, you get the 3 ohm resistor current and 1 ohm resistor current and final current. You can find easily. Na?
That that I
Then same same phenomena you can apply like current divider rules. Okay, let can same circuit can you draw like that for finding the current. This is a final voltage. Find this current. Suppose I1 find this current, I2 find
okay.
this current, I3 same current is following I1 because of this is same. Find current this one. Suppose I4, I5. Then what is the
The-
then after
My
you
doubt was like that I where that I goes.
okay. First I'll find all of thing, all current. Na this
Hmm.
current, this current, this current. Then find join this one. Asking this current. This current will find from here. This current find here. Then what is the node? Apply KCL on this node. This current,
Okay.
this
That's why I'm asking. Sir, like first I have to remove I.
okay. We can remove. First, we'll find the current, all current in the
Okay.
any two branch. This
Okay.
branch, or this branch, this branch. Then
Okay.
after apply a KCL in it or node. Then you'll find the gate. This current is equal to this current and this current. They just some
Okay, sir.
differences of current. Okay.
Okay.
Question third. This question already solved or can I solve this one?
Sir, previous
Yes, sir.
problem.
This is new one.
Previous one. This one.
Yes, sir, this one a little bit down, sir.
Yes.
Here, we want to find VAB, no, sir. So 1 by 2C should we take, no, sir?
1 by 2C.
Sir, VAB equal to 1 by 2C integral of like that.
Okay, this one, na? Final integral.
Yes, sir. 1 by 2C should we take, no, sir?
Yes. There's 1 by 2C. If there's a current, there's a 2C. It will be 2C. I think. There's a 2C. 6C. This will be a 150. 5. This will be 6. Na? Think. Yes.
Sir, 5 ones are 5 30s are 30 by 6, 5 only, sir. Yes, sir, correct.
This will be 30. These. So 5 by 2, I think 2.5 is there.
No, sir. Here, if you see means 150 by here cos 5t by 5 is there, no, sir?
Cos the sign indication of sign is negative, minus of cos 5.
Yes, sir. There by 5 is there. 5 ones are 5 30s are above 30, I think. 5 sir, below cos 5t there is 5, no, sir?
Yes, that's why I've taken this one, 25. 6 is 25, 5 is here of this 5. This 5 is this one. And
Oh,
this
yes, sir.
this this is a 25. And 5 the 5 by 2, 1 minus cos 2.5, 1 minus cos 5t.
Oh, yes, sir.
I think there is a not option. Okay, no problem. But it
Sir, sir,
yes,
150 by 6 means then
150 divided by 6 is 25, na?
then I think there is no 2, sir. Here, after
No,
6
no.
150.
C is the value, capacitor value, 2 millifarad.
Oh, okay, okay, sir.
That's why. Okay, no problem. Let's if you take 1C, that's time we will get the all of thing. But there is 2C, it will be 2C. Okay. Next, in the diagram given below, length of AB is this one question is solved by the by her or not?
No, sir.
Okay. The diagram given below, length of AB is equal to 4 meter, BC is 1 meter, and CD is 3 meter. Length is given, this one is a 4 meter, this one 1 meter, this one 3 meter. Okay. Also, A from A to B resistance is varying as a function of R. R is equal to R naught into R. In this case, varies from R naught into R. Okay, and also from C to D, resistance varying from R naught into R square. R naught into R square is here. Whereas the distance from A, R is distance measured from A to here, like that. And RBC is given 2 ohm. RBC already given as 2 ohm. Then find the total resistance A to B. R A to B asking the question. Then what is this one? RAB, this resistance, plus RBC, this resistance, plus RCD. RBC is given as 2 ohm. We have to find RAB and RCD. Okay. Resistance vary from 0 to this one length, R length. If there is a, then how can you find this one? RAB. First find the RAB.
Sorry, sir. Excuse me.
Yes, yes, yes.
Sir, can you save this recording today only if possible? Today night.
At
On
night.
YouTube, you can upload
Yes, yes,
possible.
yes. I want to upload this one. I
Sir.
think it will be take. I think 10:30 approx. 10:30 or
Okay.
11
Thanks.
p.m.
Okay. Thank you. Thank you.
Okay. RAB. How can you find the RAB? RAB is given as the function wherein is R naught into R. It means this will be varying with respect to R naught into R. It is a linear equation because of R naught is fixed value 2. The length is given 0, 1 meter, 2 meter, 3 meter, like that. Okay. Then how can you find the total resistance in this case? Total resistance RAB can you find by the using integration, because of it there is not exact value is given. Resistance is given as a R is distance from A. It means if resistance is because of this is the bearing resistor, not a constant resistor. Bearing resistor and bearing resistor is depending on the distance. If you go distance is from far from A, then resistance will be vary or increasing. That's why this is phenomena. Then we have to integrate from 0 to 4 meter. This is a 4 meter channel. That's why 0. This one here is a 4. 4 meter R resistor is given R naught into R respective to D. This will be R naught into R square divided by F 2. Integration of this one 0 to 4. Then this will be R naught into R naught by 2 R square into 4 square is 16 minus 0 is 0. R naught is given. I write this one higher. R naught is 2 given in the question. 2 into 2 16 minus 0 is equal to 16 ohm. Okay, RAB fine. Then what is the RBC? RBC is given in the question 2 ohm. And what is RCD? For RCD, there is another wiring resistor is given. Which one is R naught into R square? It means this will be looks like that. From here to here, from 4 meter to 5 meter. From 5 meter to 3 here is 8 meter. Integrate from 5 to 8. Suppose this is the 5, 6, 7, 8 in meter. Then we have to integrate this one RCT. Integration from 5 to 8 R naught square into dr. Then this will be R naught into R cube by 3 from 5 to 8. R naught is 2 by 3. 8 cube is equal to 512 minus of 5 cube is equal to 125. To solve this one, then this will be 2 of 58 ohm. Okay, then total resistance RAD is equal to RAB plus RBC plus RCD. This is 16 ohm. This is 2 given in the question, 258, and by this calculation the total is 276 ohm. Okay. There is a wiring resistance is given. Wiring resistance is vary depends on the resistance from A. The question is given is to find the ratio of V out and V in the circuit given below. You have to find V out divided by a V in. How can you find this one? This same question, same circuit diagram, you can follow. Find this one like that. Both ground is connected to ground. V in. This is GM, V1. This is RD. This is the output voltage. V out from here to here. This is RS. Okay, but if there is connection between them, then you can you can draw this circuit diagram like that. But there is a connection. There is not connection between them. That's why this is the open circuit. And this voltage is given as V1. Okay, this voltage is controlled that this current source. Then by the KVL you can apply here. This is a current passing flowing through this branch also. Then what is the voltage of this one? Current into resistor, and this will be GM V1 into RS. Then what is the V in? In the case KVL in this loop, V in is equal to V1 plus GM V1 into RS. It means V1 if you get the common 1 plus GM RS. V in is find from this one. And what is the V out? Same current is passing through like that. Then is entered from negative side. Then what is the V out? V out is equal to minus of this current and this resistor, minus of GM V1 into RD. V out is equal to minus of GM V1 into RD. Then what is the V out divided by of V in? Minus of GM V1 RD divided by of V in. V in is equal to V1 1 plus GM RS is equal to minus of GM RD divided by of 1 plus GM RS. Okay, this is the final answer. This is the next question, and this one is the last question. Given, let's say that there is an element as shown below where current and voltage flowing follow the relation V is equal to log of P1, where P1 is the sum coefficient for the given material, same as the R, L and C. It means there is some element, okay, as there is some voltage and this one a current flowing through it. Now let's say three element with coefficient P1, P2, same coefficient. There is a three element P1, P2 and P3 in connected in series. Then what is the effective coefficient P for the whole material? This one is given as V is equal to log of P1. And what is this voltage? This whole voltage same log Vp1, Vp2 and Vp3, all are connected in series. and total is the VP. Total voltage is VP in this case. Okay. And what is the VP is VP1 plus VP2 plus VP3. VP is given in the question like a log of P1, a log of P per VP. Per P1, this will be log of P1, this will be log of P2 plus this will be log of P3. Log A plus log B is log A into B, P1 into P2 into P3 in this case log P. And what is the P? Coefficient is P1 into P2 into P3. Okay. Then okay everyone, I want to stop here for the today class. Then I will meet to you on next Tuesday for the next session.
Thank you, sir.
Okay. Thanks to all.